Now then, here's an interesting little project. This is an Aga kettle. Now for those people who don't know, an Aga is one of those big kitchen ranges, and they can run on gas or oil or coal or all those sorts of things. You know, you get some really big old ones, and this is quite an old Aga kettle. Because it sits on just a complete flat plate, then the surface area of the bottom is big compared to the depth, so you've got a lot of heat transference. So I'll just zoom you in to see this, but there's a problem with this. I think this has been used for decades in an area where the water is slightly acidic, and even though the bottom of these kettles is very thick, so it doesn't wear away, there's a point where it looks like the combination of use and acid water, and maybe stood with water in it for a long time, you know, frequently, and all those sorts of things, or sat there just on the side of the hot plate, just sort of just steaming away. There's a little hole in the bottom, and I've been asked to do something about it. Anyway, let's just zoom in and have a look. There we go. Agaluxe. It's quite robust. See the handle's nicely riveted on, etc. So we have a hole just there. I'll see if I can zoom into that. See there? So I've got a dressmaker's pin, and it goes all the way through. So what are we going to do about that? I think we put a dolly on the inside and peen this over from the inside and the outside. You see, if it had been in a hard water area, that would have filled up with limescale, but because it's in a slightly acid water area, it's eating it away. Let's give it a go, shall we? Because obviously at the moment it drips out of there, and then you put it on the top of the Aga, and you get these little steam explosions. Right, let's crack on. So I've taken this bit of steel bar and rounded off the corners so it don't bite in. Yeah, this is a bit of that steel that I used for the pivot for that Denby pillar drill motor mount. So now I'm just putting that there. Right, so we've squashed that down a bit, and the hole is smaller, but it's still a hole. So I think we'll need to now do it from the inside against a dolly of some form. Actually, looking at this, and you won't be able to see, but there's actually a hole or a crater in the inside, just where this bottom is really thick. It must be at least, well, 3/16 thick by the looks of it. But I can see that little hole and a crater around it. I wonder if we can just get the camera in there for you to see.
Yeah, you see. Yeah, there's a little crater there, so we'll just see. I might have to fill this in with a rivet. I think that will be the idea. So there we go. I've mainly painted that over on the inside. You can just about see the original hole, but I think that has fixed the job, because I've caved in that cavity on the inside, painted it all over. But we will find out. But first of all, there is another area of corrosion just down there, right on the edge, well, just a quarter of an inch up the wall. So we're going to have a look at that next. So that one there, I thought I'd just investigate, because it had again a huge crater or a pit, and it's turned out to be a bigger hole than the one in the bottom. So what we're going to do about that? Well, I've looked in my box of miscellaneous rivets, and there we go. There's some aluminium rivets. I think we've only got two sizes, that one and that one. So one's a dome head and the other is a flat head. So I think we'll try the flat head first and see what happens. The dome head is, I don't know, 3/16. The flat head, or slightly countersunk, is 1/8 maybe, a bit less than that. We'll see which fits, and I'll get back to you when I've started the process. It's a bit more than I expected, this job. I think I'm just going to have to put a little drill in there and drill that out, and that will just about fit, and we'll have to cut this to length. I suppose that ought to go on the inside so we can rivet the outside properly. Right, let me just drill that hole out a bit. Right, well, the edge of that hole was incredibly crusty and thin, so I started to drill a little bit and it was just collapsing. So we've just got here at the right time. We fixed the bottom one, and we could have returned this, and then within a short while it'd be leaking out the side. So I've drilled it out to take one of the big rivets, and that should be all right. Like that. But what I'm going to do is put it from the inside, if I can find it, like that, and then mark it with the junior hacksaw, cut that off, poke it in there and rivet it over, and hopefully that will do the job. It'll be a bit rural, but rural's alright. So let's just crack on with that, and if it's wrong we'll still drill it out and do it again. Okay, so I've shortened that rivet, and let's just try and get that through the hole. Now the rivet's shorter, it's a lot more difficult to deal with, which is about par for the course. One. There we go. Right, we need a dolly in there, and then we need to peen that over. So I've got a slightly smaller diameter rod, which looks like it's going to work. Right, that dolly is not actually holding that rivet in place very well. Let's try it like that. No. Okay, I've got here a 2 pound weight from a set of scales. That will work as a nice dolly, and as you can see it's got a taper on it. So we put that in there against the edge, and that's working well. As you can see, yeah, brilliant. That's done it. Excellent. I'll just clean that up and then we'll give it a road test. Just goes to show every day's a learning day. So it's another day, and I've got this bit of 12mm rod here, and as you can see I've drilled a bit of a hole in there in the end. That will act as a socket for the head of the rivet. And the other thing that's sort of not even interesting or entertaining is, as I riveted that rivet in the side, all that area crumbled away, so it was sort of paper thin. And what I'm thinking now is there was not a lot of limescale in there, so either this kettle has been cleaned with an acid cleaner regularly, or it's been in an area where there's been slightly acid water and it's been sat on the top of the hob just bubbling away gently, and you can imagine the boiling bubbles coming from a specific area and it just slowly eating the aluminium away. Having said that, I had an aluminium head on a car surfaced 2 or 3 years ago, might have been longer, and I was talking to the guy who was doing it, and he said that majority of problems in our area with head gaskets going and cylinder head problems was the fact that there was lime in the water, and you should never top up your car with tap water. Apparently the lime reacts with the heat and the the aluminium, and it erodes the aluminium away where the water passages are through the head gasket, and therefore sort of starts to rot everything away. So who can tell what caused these? But it's pretty old. I mean, I'm thinking this kettle is 60 years old, and it looks like it's had quite a hard life or a lot of use. Anyway, so what I propose to do now, because the hole is so big, I've got a curved washer that I'm going to put on the inside and a washer on the outside, and I will put some Boss White plumbing compound between the two, and let's just see how that works. Right, let's just see what happens. Stick that on there, and this is the stuff for domestic water, and if you were using iron fittings you would use this and hemp fibre. You put this on the threads, and then you'd put the hemp fibre, wrap it round, I don't quite like that. That needs flattening out a bit more. And so therefore it seals all the threads. Still don't like that. That's better. That's a lot better. So that goes on the head of that rivet and locks that in place. That's good. That feels solid. And that feels solid. And then I just clean that up with a wire brush. That won't move. Hopefully that will do the job. Okay. And it doesn't look like any leaks from there or where are we, here. I'm pleased about that. That'll do nicely. So there we go. An antique looking repair as it is. Yeah, nothing posh. That's what you would get in the old days. Just fix it as soon as you can. What I suggest with this is, as we do with our kettles, because we have a lot of problems with lime scale, is put a seashell in there.
So therefore with ours, over time the seashell just gets bigger and bigger as the lime is deposited on it. And with this one, if it's in an area where there's acid water, put a seashell in it and it will neutralise the acid in the water and slowly get smaller. And of course the other thing is, don't leave it ticking over on the hob just halfway on the boil. Always move it off, because that's obviously another thing which would start the corrosion going. Hope you've enjoyed this. Comments would be appreciated, especially from somebody who knows about aluminium, some metallurgists, and catch up with you soon. Cheers for now.